Now we focus on a different concept, and that is nomenclature of carbonyl compounds. What am I saying here? Aldehydes and ketones, how do we name them? According to International Union of Pure and Applied Chemistry, they are named by replacing the suffix ane. We replace the suffix ane in the alkane that gives rise to the parent chain. We replace that suffix with this suffix, or that, depending on whether I am naming an aldehyde or a ketone. So if I am naming an aldehyde, I replace ane with ANAL, as we are going to see in our examples. Then if I am naming a ketone, I replace ane with ONE, as we are going to illustrate. Then other rules, don't forget that other rules such as giving the functional group priority. What do I mean by saying that we give the functional group priority? You assign it the least position. Maybe if you are numbering or assigning positions to the carbon atoms that exist within the parent chain, you ensure that the functional group, which is the carbonyl carbon, you ensure that the carbonyl carbon is assigned the least position before naming. So to ensure that, you have to assign the carbon atoms positions from either side. What do I mean? If, for example, I have CH3, CH2, CO, CH2, CH2, CH3. I number the carbon atoms. This is 1, 2, 3, 4, 5, 6. That is from my left to my right. Then also from the right-hand side to the left-hand side, you have 1, 2, 3, 4, 5, 6. I do that to ensure that CO, to ensure that where I have the carbon carrying the oxygen, the carbonyl carbon, to ensure that the carbonyl carbon occupies the least position. Yeah. So we now look at examples. So in my examples, I start with aldehydes. Don't forget, we have said that generally, according to IUPAC, we replace ane within the alkane that gives rise to the parent chain with ANAL or ONE, depending on whether I'm naming a ketone or an aldehyde. So I start with aldehydes. We want to write down the IUPAC names of the following compounds. So this is my first example. You can very well see that it is made up of one carbon atom. And if it is a one carbon atom within the chain, one carbon atom within the chain, that is methane. That is methane. But this is not an alkane. So if it is an alkane, it is methane because of one carbon atom. But according to how I have interpreted my IUPAC rules, instead of having ANE, we replace ANE with ANAL, since this is an aldehyde, to come up with methanol. Then also in this example, there are two carbon atoms. There are two carbon atoms, and if it is an alkane, that is ethane. So instead of having ethane, I'll have ethanol. I'll have ethanol, which I have generated by replacing ANE in ethane with ANAL. Another example, this is the third example which I have. It is made up of 3 carbon atoms. If there are 3 carbon atoms, that is propane. That is propane. So instead of having propane, I'll call it propanol. Call it propanol. Then for the fourth example, I have a branch. You can see that the chain, the parent chain which has 3 carbon atoms, has a group which is appending from it. Therefore, if I have a group appending from the parent chain, I number the carbon atoms within the chain to identify the least position of the functional group and also the position of the group appending from the parent chain. So therefore here, this is 1, this is 2, this is 3. I also assign them from the right-hand side to the left-hand side. So meaning that this is 1, this is 2, this is 3. Then I look at the functional group first. The functional group must be given priority. What do I mean by saying that it must be given priority? It should take on the least position. What is the functional group in this case? The functional group in this case is CHO. This CHO, since I'm naming an aldehyde. So considering the first numbering where I have 1, 2, 3, you realize that CHO is at position 3. Then if I consider the numbering down, we have 1, 2, 3. You realize that CHO is at position 1. Therefore, I go with this down numbering because it is the one that gives CHO the least position. On that note, if I consider the numbering down, CHO is at position 1, then I have 1. At 2, I have the methyl group. Therefore, the name becomes, if I don't look at the methyl group, the methyl group, there are 3 carbon atoms. So that is propanal. There are 3 carbon atoms, and that is propanal. Now, looking at the methyl group, the name will be 2-methyl. 2-methyl propanal. Then another example, we have this example. Still I assign positions. I number the carbon atoms within the chain. This is 1, 2, 3, 4. From the left to the right, and then I also number from the right to the left. This is 1, 2, 3, 4. After assigning them positions, I look at the functional group first. You have to first consider the functional group without looking at any other thing. You have to first give it priority. So if I consider the first numbering, the numbering up, this numbering up, you realize that CHO is at position 4. Then the numbering down, you realize that CHO is at position 1. Therefore, I go with the numbering down. Why I go with the numbering down? Because it is the one which is giving the functional group the smallest position. So going with the numbering down, at 2 and 4, I have branches. And at 2, that is a methyl group. And at 4, that is a chloro group. I think chloro, C comes first. C comes first according to alphabet. This is C, chloro group. This is methyl. So here we consider alphabet. Don't forget those basic rules of nomenclature. So we go with the chloro first. So we shall have 4 chloro, 4 chloro, then 2 methyl. There are how many carbon atoms? There are 4 carbon atoms. This is one name. Just that here I don't have space, but this is one name, butanal. Don't leave spaces. So that is the name, 4-chloro-2-methyl butanal. I think I can take now this off. We've taken note of it. That one has been named. Then I also look at another compound, this one here. Still I assign positions. This is 1, 2, 3, 4. From either ends, this is 1, 2, 3, 4. You give CHO priority. So you look at you look at both numberings, you look at both of them, you realize that the one which is up, CHO is at position 4, which is not smallest. Then down, CHO is at position 1, which is smallest or least. So I go with the numbering down. Going with the numbering down, at 2 and 3, I have branches. At 2, I have bromo. At 3, I have methyl. What comes first? B. Therefore, the name will be 2 bromo, 3 methyl, 2 bromo, 3 methyl, 2 bromo, 3 methyl. There are 4 carbon atoms, butanol. This is one name. Just that here I don't have space, but it is 2 bromo, 3 methyl, butanol. No spaces. No spaces here. Hope I'm clear. No spaces. Just that here I don't have enough space. Then this is without CHO. Without this CHO, it is cyclohexane. Without CHO, it is cyclohexane. Now considering CHO, this is cyclohexanol. Same thing here. Without CHO, it is cyclobutane. Because of the 4 carbon atoms, now considering CHO, it is cyclobutanol. Cyclobutanol. Then this is a phenyl group. Without CHO, it is benzene. Without CHO, it is benzene. Now with CHO, it is benzenol. However, its trade name is benzaldehyde. So if you benzaldehyde, if you hear people mentioning benzaldehyde, we mean that. However, one can also call it phenyl because as benzene as a branch or as a substituent, it is interpreted as phenyl. So one can also look at it as phenyl methanol. Phenyl methanol. Phenyl methanol. Phenyl, the branch, but we have 1 carbon atom. 1 carbon atom. So phenyl methanol. Then here, without this NO2, without the NO2, that is benzaldehyde. Without NO2 is benzaldehyde or benzenol or phenyl methanol. Now considering NO2, this is 1, 2, 3. Therefore the name becomes 3. At 3 I have NO2 is nitro group. So this is 3 nitro benzaldehyde. Here I don't have space, but it is one name. 3 nitro benzaldehyde. Then this one, still we have a branch. We have a phenyl branch. Without this benzene ring, without the benzene ring, a moment. With this example, without this phenyl group, without this ring, it is ethanol. It's ethanol without the ring. Now considering the ring, meaning that the ring is a branch, therefore we number the carbon atoms here. This is 1, 2. Starting from the left to the right. Then also from the right to the left. This is 1, 2. Don't forget CHO is considered first. So if I look at this numbering up, CHO is at 2, not given priority. So I don't consider that. Then down, CHO is at 1. So I go with that. However, if I go with where CHO is at 1, then at 2, I have a branch. So the name becomes 2-phenyl ethanol. 2-phenyl ethanol. It is the same thing here without this OH, it is phenyl ethanol. It is phenyl ethanol. Therefore, if I consider OH, we shall have 1, 2, 3. I have said first, without OH, it is phenyl ethanol. No, sorry, it is not phenyl ethanol. Without OH, sorry. Without OH, it is 2-phenyl. Without OH, 2-phenyl ethanol. Without OH, it is 2-phenyl ethanol. This example before. Now considering OH, this is the, it is at 3 now. It is at position 3. So this is 3 hydroxy 2-phenyl ethanol. So as of now, allow me stop here. You try out this simple exercise. You name those aldehyde. Hopefully, we shall continue with ketones.